What if a water reservoir could repair its own cracks, without human intervention? Sounds impossible? Think again. In this video, we'll explore a fascinating case study where self-healing concrete was used to prevent water leakage in a large industrial reservoir and pump house. We'll cover checkmark how self-healing concrete works in water infrastructure, checkmark real-world performance and benefit, checkmark challenges and future applications. By the end, you'll see why self-healing concrete is the future of sustainable construction. Let's dive in. Why water reservoirs need self-healing concrete. Water reservoirs and pump houses store and distribute water for industrial, municipal, and agricultural use. But they face serious challenges. Cracking from hydrostatic pressure, right-pointing arrow, leads to leakage and structural damage. Temperature variations and shrinkage, right-pointing arrow, causes long-term wear and tear. High maintenance costs, right-pointing arrow, constant repairs and water loss. To solve this, engineers used self-healing concrete with crystalline admixtures to make the structure leak-proof. Now, let's look at how this was applied in a real project. Project overview, industrial water reservoir and pump house project details. Now, let's break down how self-healing concrete technology was implemented. How does self-healing concrete work in water reservoirs? Technology used in this project: healing agent, crystalline admixtures, Zypix, Penetron, Crichton, etc. Self-healing mechanism. Keycap 1 crack formation. Stress and temperature changes cause microcracks. Keycap 2 water infiltration. When water enters, it activates dormant crystalline compounds. Keycap 3 crystal growth. The compounds react with moisture, forming insoluble crystals. Keycap 4 crack sealing. The crystals continue to grow, sealing cracks up to 0.5 mm permanently. This ensures the reservoir remains watertight, preventing leaks and reducing maintenance. Performance evaluation. Does it really work? Pushpin 1-year monitoring results. The self-healing concrete exceeded expectations, proving its effectiveness in water infrastructure. Key benefits of self-healing concrete for water reservoirs. Why is this a game-changer for water infrastructure? Prevents water leakage, eliminates the risk of seepage and contamination. Extends service life, reservoir lifespan increased by 25–30%. Reduces maintenance costs, estimated 50% lower maintenance expenses over time. Sustainability and water conservation. Less water loss equals more efficient resource management. This technology saves money, water, and the environment. Challenges and solutions. What were the biggest challenges? Though initial costs were slightly higher, the long-term benefits far outweighed the investment. Future of self-healing concrete in water infrastructure. What's next? Advancements in self-healing concrete, combining crystalline admixtures with bacterial healing for better performance. Developing enhanced crystalline compounds that seal cracks up to 1 mm. Applying this technology in large-scale projects like dams, canals, and desalination plants. Using AI-driven monitoring systems to detect and accelerate self-healing. With ongoing research, self-healing concrete could redefine the future of water infrastructure. The future of leak-proof infrastructure. This case study proves that self-healing concrete is not just a concept, it's a real-world solution for sustainable and long-lasting water infrastructure. Why should we invest in this technology? Eliminates water leakage and reduces maintenance costs. Extends the lifespan of critical infrastructure. Supports sustainable water conservation efforts. Should more countries adopt self-healing concrete in their water infrastructure? Comment below. Like, share and subscribe for more innovations in engineering and sustainable construction.